Hello students, welcome to Aspire Academy. Today we are going to start a new chapter, coordinate geometry. Okay, it's your chapter number 7, coordinate geometry. Okay, so before starting our first topic, that is distance formula. Okay, so first of all, let us try to understand what is coordinate geometry or what is coordinate. So you all know in class 9 that suppose here you have to locate a point or you have to locate something. Okay, so for locating a point or locating something or some place, okay, what you have to do, you have to say that the point or the location of that place from north side or from west side or from east side, where it is, where the place is placed. Okay, so suppose here in the board a point is there, right? And this point, if I say if I ask you that what is the location of this point, okay, suppose someone said that sir, the point is above the means the point is above the ground, above the ground at a distance of 10 centimeter. Okay, so that means what? That means I will understand that this point is at the 10 centimeter height. Okay, from this point 10 centimeter height, right? But the thing is, if we take a point at the same distance, okay, at the same height, this point is also at the 10 centimeter height and this point is also at the 10 centimeter height, right? So by saying that this point is at the 10 centimeter height from the ground, okay, you can't locate the exact location of that point, right? So what you have to tell, you can tell that the point is above the ground at 10 centimeter height, and you can say that from the right, okay, from the right portion the point is at the 15 centimeter from the right. Okay, that means from right side it is at the 15 centimeter. In that case we got two values here, right? One is 10 centimeter vertically and one is 15 centimeter horizontally. Okay, that now if I say, if I have to locate the point, then I will say, okay, now the point is 10 centimeter above the ground. That means this point can be here, here and here also, here also. Okay, all these points, all these 4 points are 10 centimeter above the ground, right? And next I have to need this point also, need this distance also, that is 15 centimeter from the what? From the right side, right? If I know that it is 15 centimeter from the right side, then I will know the exact location of this point, because from 15 centimeter from the right and 10 centimeter from the ground, okay, only one point can be here. This point is the location of this point is 10 centimeter from the ground and 15 centimeter from the right side, right? If I say about this point, okay, this point is 10 centimeter above the ground, it is right, but this point is not 15 centimeter from the right side, it is more than 15 centimeter, right? So the thing is, what I want to what I want to discuss, that if we have to locate a point, any kind of point or any kind of thing, okay, we have to say 2 points here, okay, one is from vertically and one is horizontally. Okay, we have to give them two measures. What measure? One is one is vertically, that means it is from the top or bottom, okay, and one is in horizontally, okay, that is from the right hand side or left hand side, you can say. That means for a point, okay, it can be known by two direction, that is x and y. What is x? X is at the horizontal level and y is at the what? Y is at the vertical level, okay. So today we are going to start a new chapter. It's called coordinate geometry, okay. So in class 10 you have the first topic of coordinate geometry is distance formula, okay. So before starting the topic, okay, we have to know what is coordinate geometry, right? So we all know what is coordinate geometry. Suppose we have to locate a point, for the location of that point we have to know the coordinate geometry, okay. But we can say that what is the coordinate of that point. So suppose this is a graph, okay, this is a two-dimensional graph. This is x point and this is y point, y axis. This is x axis and this is y axis, and this is 0, means origin, right? So suppose a point is there, right? This is 1 2 3 4, 1 2 3 4, okay. So I am saying that locate a point, okay, whose location is 2, 3, okay, or we can say plot a point in the graph, okay, whose location is 2, 3. So what is 2 here? 2 is x axis, okay, and 3 is y axis. That means what? Thus 2 is here what is x axis means what? From origin we have to measure 1 2, okay, this is the 2, and 3 is 1 2 3. So we can say this is the point, right? So we will all know this thing, right? How to locate a point or how to plot a point in the graph, okay. So now we will start our topic, that is distance formula, okay. Next, so first we have to derive the distance formula, okay. How can, there is a formula, okay, in the coordinate geometry to measure the distance of 2 points, okay. Suppose this is a point and this is a point A and B, okay. If we want to measure the distance between these 2 points, okay, measure the distance of these 2 points, or we can say if we want to measure the length of AB, okay, then we can apply a formula, okay. We can apply a formula, and by this formula we can easily measure the distance of AB, or we can say we can easily measure the length of AB here, okay. So now here this is a graph, right? This is x axis or this is y axis, and this is origin, okay. Here what I have drawn here, a line, okay, or we can say a line segment. Suppose this is a point A and this is a point B, okay, and what I have done, I have joined this both point AB, okay, and so I got a line segment here AB, okay. So now what we can do, we can measure the length of this AB, okay. Now we derive the formula, okay, for how can we measure the length of this AB, or we can say how can we measure the distance between AB, okay. So first of all suppose the coordinate of AB, let the coordinate of AB be x1 comma y1, okay, and coordinate of B x2 comma y2, right? Now we have to draw a perpendicular on x-axis from point A, and we have to draw a perpendicular on x-axis from B point. Okay, then from point A we have to draw a perpendicular on this side. Okay, we can side, this is R and this is S. Okay, on a BS we have drawn a perpendicular, we can say AT. Okay, now see, so A x1 y1 comma B x2 comma y2. Okay, and here see, the location of this point, A point, is x1 y1. So what we can say, from O to R, this is x1, right? This is x1, and from A to R, or we can say from, if we measure this point at here, okay, from O to this point, this is y1. That is why the location of this point is what? Is x1 y1. Okay, so we can say here that OR equal to x1. Okay, next for point B also. Okay, x2, what is x2? In the x-axis from O to S, this is x2, right? So we can say OS equal to what? x2. So what will be the RS here? Okay, we know that OR equal to what? OR equal to x1 and OS equal to what? x2. Okay, if we subtract OR from OS, then we will get what? We will get RS here, right? So RS equal to what? We can say RS equal to OS minus OR, right? What is OS here? OS is x2, so x2, and what is OR? OR is x1. Okay, so RS equal to x2 minus x1, and this RS equal to 80, right? This distance of RS, the length of RS is equal to 80, so we can say equal to 80, right? Okay, then what is AR? Okay, we can, if we say, okay, before AR we can say what is SB. See, here from O to S, okay, OS is x2, that's why the coordinate of B, the x coordinate of B is x2, and BS, right? This BS is what? Is y2. Okay, so SB or BS, whatever you can say. Okay, SB equal to what? SB equal to y2. Okay, next AR. Okay, AR equal to what? OR equal to x1. Okay, that's why the x coordinate of A is x1, and what is y coordinate? Y coordinate is y1. So what will be the y coordinate? This is AR, right? AR equal to what? AR equal to y1. AR equal to y1, and this length of this AR is equal to the length of this TS. Same, okay, this much AR is equal to this much TS, right? So we can say equal to TS. TS equal to also y1. So from here also we can say, if we say this BT, what is BT here? BT will be, if we subtract TS, okay, from BS, then we will get this BT, right? So BT equal to what? BS minus TS. Okay, what is BS? BS is y2, and what is TS? TS is y1. Okay, so we got here BT equal to y2 minus y1. Okay, now okay, here ATB, right? This ATB is a what? Is a right angle triangle. Why? Because this AT is perpendicular on this BS. So this angle is right angle. Okay. So here if it is a right angle triangle, then we can use what? We can use Pythagoras theorem, right? So in triangle ABT, using using Pythagoras theorem, AB square equal to what? AT square plus BT square, right? So from here AT square equal to AB square equal to AB square equal to AT square plus BT square. So what is AT? AT is x2 minus x1. So we can say x2 minus x1 whole square plus what is BT? BT is y2 minus y1. Okay, y2 minus y1 whole square, right? So okay, for, at the first, okay, at the first what I have told you that we have to measure the length of this AB, right? Or we can say we have to measure the distance between this AB, A point and B point. So here AB square is there, okay? So what we have to take, if we take the square root, then it will be AB, and what we will get, this will be root over x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so from here we got the relation, or we can say we got the formula of the distance formula, okay, of distance between 2 points. That is what? That is AB equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so what is x2? From here we can say x2 is the x coordinate of B, right? What is x1? x1 is the x coordinate of A, right? What is y2? y2 is the y coordinate of yes, y2 is the y coordinate of point B, and y1 is the y coordinate of point A, right? So by this formula, or using this formula, we can easily measure the distance between any 2 points. Okay, instead of AB, a line is there, PQ, right? And suppose, okay, I am doing an example here. Suppose a question is there. Suppose you have to measure the length of this line, right? P is what? Suppose P is 2, 3 and Q is 4, 7. Okay, coordinate of Q is 4, 7, right? And if you have to measure the length, or if you measure the length of this PQ, then you can say directly PQ equal to, what is the formula? x2 minus x1 whole square plus y2 minus y1 whole square, right? Equal to, what is x2 here? Okay, see, this is Q point, so x2 will be what? This 4, right? Because 4 is the x coordinate of point Q, right? So 4 minus 2, 2 is the x coordinate of point P. 4 minus 2 whole square plus y2 minus y1. The y2 minus y1 will be 7, minus 3 whole square, right, equal to, this will be 2 square plus 7 minus 3 whole square. So 7 minus 3 whole square means this will be 4 square, right? So this equal to 2 square means 4 plus 4 square means 16. So 4 plus 16 will be root over 20. Okay. So for 20 means, root over 20 means we can say 2 root over 5. 2 root over 5. Okay. So the distance between this P and Q is what? 2 root over 5 unit. Okay. So whatever the unit is, centimeter, meter, we have to use here. Okay. So by this method or by this formula, we can easily plotting these coordinates of 2 points. Okay, we can easily measure the distance of any kind of straight line. Okay, not only straight line. Okay, one, remember the thing. By this formula, we can only measure the length of straight line. Okay. Now, okay, example 2. So example 2 is, so that the points 1, 7, 4, 2, minus 1, minus 1 and minus 4, 4 are the vertices of a square. Okay. So okay, what is the question here? So that these points, okay, these points are the vertices of a square. Okay, so what is square? Square means, suppose it's a type of quadrilateral where all the sides are what? All the sides are equal, right? And suppose this is A, B, C, D, and these points or these coordinates are the vertices of these points. Okay, means coordinates of these points A, B, C and D. So now the you have to do what? You have to show whether these points are the vertices of a square or not. Okay, so for this what we have to do, if it is a square, okay, if it is a square, then the length of AB, length of BC, length of CD and length of DA should be equal, right? Okay, now what we have to do first, we have to measure the length of AB, BC, CD and DA. Okay, again one more thing, one more quadrilateral is there whose all the sides are equal. What is that quadrilateral? That is rhombus. Okay, that is rhombus, right? So between rhombus and square, what we have to make, we have to know the difference between rhombus and square. So the, okay, so the between rhombus and square, what is the difference? That diagonals of square, both the diagonals of the square are equal, but both the diagonals of a rhombus are not equal. Okay, so for this what we have to do, we have to also measure the length of the diagonals also. Okay, then only we can say if the 4 points, okay, if these lengths AB, BC, CD and DA are equal, okay, then also we can't say this is a square. Then we have to measure the diagonals also. Okay, if the measure of these diagonals are equal to each other, that means if AC equal to BD, okay, then only we can say this is a the points are, or these points are the vertices of a square. Okay, so first of all, let A 17, B 42, C -1, -1 and D minus 4 comma 4 are the vertices, okay, are the 4 points, are the 4 points or are the 4 vertices, we can say, okay, 4 vertices. Now we have to measure the length, okay. First of all, AB. The formula is x2 minus x1 whole square plus 2 minus y1 whole square, right, equal to x2 minus x1 is what? Between this A and B, what is x2? 4 minus 1 whole square plus y2 2 minus 7 whole square, okay, equal to 4 minus 1 3 square plus 2 minus 7 minus 5 whole square, equal to 9 plus 25, right, because minus 5 whole square will be 25, so 9 plus 25 will be what? Root over 34, right. So okay, so this is root over 34. Next, BC. So BC, B and this C, okay. So what is BC? This is also same formula, x2 minus x1 whole square plus y2 minus y1 whole square, okay, equal to what is x2? Minus 1. What is x1? 4. So minus 1 minus 4 whole square plus y2 minus 1 minus, this is 2, okay, so we can say minus 1 minus 2 whole square, equal to, this will be minus 5 whole square plus this will be minus 3 whole square, okay. So 25 plus 9 equal to, this is also 34, okay. Next, CD. So CD is also CD minus 4 minus 4 minus of minus 1, so this will be plus 1 plus 4 minus of minus 1, this will be 4 plus 1, 4 plus 1. So minus 4 plus 1 will be minus 3, so it will be minus 3 whole square plus this will be 5 square, okay. So 9 plus 25, this is also 34, right. Next, CD is done. Now AD. AD. So AD is A and D, okay. So x2 is minus 4, x1 is 1, so we can say minus 4 minus 1 plus 4 here 7, so 4 minus 7, 4 minus 7, so this is minus 5 square plus minus 3 square, so this will be also 34, okay. So here AB, BC, CD and DA all are equal. AB root over 34, BC, CD and DA all are equal, okay. Now what we have to do, we have to measure the length of the diagonals. So first diagonal is AC. AC. So A and C. So minus 1, minus 1. Okay. Minus 1 whole square plus minus 1 and this is minus 7. Minus 1 minus 7. So this will be minus 2 whole square means 4 plus minus 8 whole square means 64. So it will be root over 68. BD. BD is the second diagonal. Okay. So what is BD? BD is 4. This minus 4 minus 4. Minus 4 minus 4 plus 4 minus 2. 4 minus 2. So minus 4 minus 4 minus 8. Minus 8 whole square means it will be 64. 4 minus 2 2. 2 square means 4. So 64 plus 4 it will also 68. So both the diagonals are equal, right? So therefore AB equal to BC equal to CD equal to DA and AC equal to BD. Therefore ABCD is a square. Okay. So this is our first example. Okay. So in the next class we will continue it. Thank you.